continue from previous video where we apply the virtual unit load 1 Newton and we find the internal forces N1, N2 and small n3. Now for the same thing we need to calculate for the real loading. Let me draw the first one, the virtual one that we calculated. We have this pin support, roller supports, and we have this point A, point C and point B, and we apply this virtual load 1 Newton. Due to this virtual load we found these three forces, 1 Newton here, this is internal axial forces, 1 Newton here, and we found minus 1.41 Newton for these members. So now let me draw the new real one, that is for step number 3. We have these pin supports, we have these roller supports, and we have same name A, C and B. Now here instead of 1 newtons we have real load 500 Newton. By looking at this one we can see this 1 Newton is changing to 500 Newton. So respectively all the internal load would be multiplied by 500. So in here if I multiply 1 Newton then I would have a 500 Newton load internal axial force. Similarly here we have 500 Newton internal axial force, and in here I would say that minus 1.41 times 500, it would give us minus 707 Newton, right? So it's just amplification. It should not apply for all the examples, but here fortunately we can find this that we can multiply by 500. So here it is simple to say, let's give them 1, 2 and 3. I can say n1 equal to 1, n2 equal to 1, small n3, this is the virtual one, 1.41 newtons. And similarly I can say n1 equal to 500 Newton, n2 equal to 500 newtons, and that's n3 equal to minus 707 newtons. So that is 1, 2 and 3. So if I know these all small n and capital N value, I can find a deflection at point B equal to small n1 capital N1 L1 over EA E1 A1 plus capital small n2 small n2 capital N2 L2 over E2 A2, and we have 3 members, so we have third one written here. Now here we have small n1, small n2, small n3. So small n1 is 1 Newton, capital N1 is 500 Newtons, and the length L1 is 2 meters here for member 1, so that is 2 meters over EA is constants, N2 is 1 Newton, sorry, capital N2 is 500 Newtons, and the L2 for the second members is 2 meters. So we can take L2 is equal to 2 meters over EA is constant plus N3 is minus 1.41 times minus 707 times square root 8 is L3 over EA. So if you're taking this length of this one would be square root 8, explained in the previous video. So if you simplify this one would give you 1000 over EA, plus it's also give you 1000 over EA, plus if you simplify this one give you 997, give you 2819.6 over EA, and if you sum them up it will get 4819.6 over EA. So that's the delta B due to this 500 Newton load. So if you know the value of EA you will get answer in meter, and then you can convert into millimeters. Thank you very much.